Hello, class, and welcome to a lesson on the formation of clastic sedimentary rocks. What I'm going to talk about is how we move from an igneous rock, go through lots of steps. We move through a fluvial environment, and fluvial means water. We're going to move through a stream, go down into an ocean, and we have graded bedding and everything. I would like you to draw along with me. You're going to do two things. You're going to draw along with me, use a piece of computer paper, printer paper, and then, or if you don't have that, just use a piece of notebook paper, no problem. Stay a couple of steps behind me so that you don't get frustrated as you're drawing, because sometimes I will erase my last little step and fix it back. So let's go ahead and get started. I think you'll enjoy this. Here we go. So first we're going to start in highlands, all right? So I have a volcano here. I'm just going to lay out the ground for the whole diagram. Just like this, coming across. So this is a steep mountainside. We come across the flat part of a continent and then drop into a lake or an ocean basin. All right, and I want that up just a little bit so that it's on my picture. There we go. Just like that. Okay, now I'm going to draw in the volcano erupting just like this, okay? And if you remember, when we learned about bimps and elves, the high part of a volcano like that, that's where you're going to have elves, right? ELVFS, where you have extrusive, lava, volcanic, fast-cooling small crystals. Down inside of the volcano, under the mountain, a mile below the ground or even more, you have a huge body of magma. This is a pluton, and this is where you have bimps. Remember this. This is big crystals, intrusive, magma, plutonic, and slow cooling. So here you have your small crystalline rocks, volcanic. This is where you have your plutonic, larger crystalline rocks. Here in the highland part of this mountain, you have lots of rain, all of stuff like that. And rocks begin to break down. All right, because of this rain, though, we have streams that form in mountains and flow all the way down just like this and form our oceans and so forth, just like that, okay? High in the mountains, you have the process of weathering, okay? Weathering, just like that. So rocks, when they're first broken down, they're not going to be rounded like you would see if you just go down to the Roanoke River and see rounded rocks. What you would have up in mountains when the rocks are initially weathered out are rocks like this, very jagged and angular. All right? This is a whole piece of quartz. This is like essentially one crystal from a igneous rock. But this particular one, this example I have, would come from somewhere like this because the crystal is so large. But let's take a look. You can remember, so you're looking here just at the shape, okay? It's angular, it's not rounded, it's rough. So I'm going to represent that with little triangles, okay? Just to show that we have angular pieces, okay? And then I'm going to write angular fragments here. And then also, something for us to notice is that this area of the mountain where it's so steep like this is also going to be high energy. What do I mean by that? What I mean is that because the stream is so steep, the water is going to rush so quickly that what it will do is it'll wash away anything. Right? Like big pieces, small pieces, anything, it all gets moved up here and moves down. Now, as the stream comes out like this, more level, you'll have lower energy, and we'll see what that does. Okay, so angular fragments, so it's weathering, and then here you have erosion. Remember, weathering is the breakdown of material. Erosion is the transportation of material. So erosion is happening, it's moving down. And as it's happening, as it's moving down, you go through a couple stages. You move from very angular fragments, and as those fragments bounce along in the river and they smash into other pieces, they will turn into more rounded pieces, just like this. See that it's no longer sharp and angular, it's more rounded. And then as this goes on down the stream, if it continues tumbling, you can actually get more and more rounded like this. A little sample from the Roanoke River there. They're kind of cool. So as you come down, I'm going to change the shape as I'm doing these. So you're still got kind of angular, but more rounded. And then we draw it on out here. And now I'm basically into rounded materials. It's not perfect. You don't always have perfectly rounded stones like this. You know, most of the time, creek stones are more flat like this. It's actually kind of rare that they get completely round, but they're certainly neat to look at. Okay, so we have weathering. Draw a line under that. Erosion. And as we move down the stream, we are getting more rounded, right? We're going to opposite this word. That's rounded. And where this is high energy, steep slope, this is a low energy environment. All right, and the energy continues to drop. And when you get out into a still body of water, what happens is there's really no energy and the sediment just drops to the bottom. We'll talk about that in a minute. Let me move my camera just a little bit. Okay, so this material continues to come on down through here. Again, you got like this whole mix of stuff just flowing down the river. You can add dots in here, like sand and all kinds of material coming down, you know, from the high area. So we have weathering, erosion, and then as the sediment goes into a deeper body of water, what happens, it comes out and it will begin to drop out, okay? It begins to drop out. This is what you call deposition. Just like that. So I'm going to turn just a little bit to focus in this area. And you remember we did our sediment bottles and we had graded bedding. Every time material goes into a body of water, you have the graded bedding. Remember here you have the large particles all the way up to the superfine particles of that mud there at the top, that clay particular matter. All right, so I'm going to draw in a couple layers of graded bedding. So large stones here on the bottom, right? And we'll come up to smaller and then finer on up to the top. All right, and then we'll draw a line to represent a layer for us. And we'll draw some larger pieces. And this repeats. You see, every time sediment is introduced into the depositional environment, you have graded bedding. Every time. Right? Remember, this shows us right way up. This is the bottom of the layer, that's the top of the layer, and it continues going on up. So we have weathering, erosion, we have deposition, and then over time, as these layers pile up and smash down, we have what's called their final process in the formation of a classic sedimentary rock. We have compaction and cementation. Remember, cementation is just a fancy word for particles getting glued together. That's all that is. All right, so there's your 4 steps. So we have, come back here, put some numbers on these. 1, fix the W. We have step 2. We have step 3. And then here we have step 4. A couple other things we want to put on this diagram, okay? First off, this whole idea that these are going to be in layers, I'm going to throw another layer in here just to make it neat looking. The whole idea that this is in layers, all right, is called stratification. Very long word, but really easy to spell. Okay, so stratification, just like this, okay? And that means layers. This is also where you would find fossils. So I'll tell you what I will do is just, I'll write this up here too. This is where you would have fossils. You always have fossils in sedimentary rocks, not in sometimes in metamorphic, never in igneous. Okay, so we look, make sure I've got everything. We have elfs, we have bents, that's igneous. We come down through high energy to low energy, go from angular fragments to rounded rocks, right rocks on there. We go from high energy, low energy, weathering, erosion, deposition, compaction, cementation. The process of layering is called stratification. This is where you would find fossils. And then you remember that this little, here, let me just do this right here. Have a line that comes up and have a little circle inset right here where you have the large material, kind of like in a book where they have the little insets and stuff. You come all the way up here, the finer material. And what that's called is graded bedding, just like that. Okay, so let me step out of the way here so you can see the whole thing. So things for you to learn, things for you to pay attention to, or is that particles, when they're high in the mountains and high energy streams, are going to be very angular, right? They're not rounded at all. But as they tumble through a stream, and you go down to the Roanoke River and you look in our basically flat-lying river that's not high on a mountain, and you see rounded stones like this, both of these are out of the Roanoke River. You know, that process of weathering is responsible for making them round. Notice that the energy of the stream, that the steepness of the slope decreases as you come down, all the way into the body of water where it goes down to like zero, and then the material deposits out. New words here, right? Stratification, brand new word for this lesson. Graded bedding is a word that we used last week when we made our sediment bottles. Remember that cementation is just a fancy word for gluing together, the compaction, and then they glue together. I think that's really it for this lesson. I would like you to take a picture of your diagram and submit it in this assignment so that I can see your wonderful work as you did this. If you have any questions, as always, please email me.